Hello everyone, welcome to MindSpan Education. So far we were discussing about the discrete random variable, and afterwards we discussed about the continuous random variable, and I think we have talked almost everything that we need to talk about these discrete and the continuous random variable. At the very beginning of the lecture we started the probabilities, we started the experiment, and we started talking about these experiment in terms of the events. There we have seen the Bayes rule. Now since we have already gone through the discrete and the continuous random variable, we are going to look at the Bayes rule variation. What do I mean by Bayes rule variations? Now we will be talking about the Bayes rule in terms of the discrete and the continuous random variable, and moreover we will also talk about the mixture variation, where we will have, for a single experiment we will have a discrete and a continuous random variable. You must have a question that why do we need to look at this? Let me just give you a simple examination of the machine learning problem where we do the classification, right? In classification problem, usually we observe the continuous random variable and we ask that in what class this object will fall. That means we are inferencing the discrete random variable, we are observing the continuous random variable. So this is the case where we usually use the Bayes rule, and the Bayes rule will have the variation of discrete as well as continuous. So what is in this lecture? In this lecture we will first recall what is Bayes rule, and then we will see the variations in case of the discrete. Afterwards we will be looking at the Bayes rule variation in case of the continuous random variable. Then we will look at the mixture, that is discrete and continuous, and we will be looking few examples of that. So let's first of all start with the recalling the Bayes rule. Let's suppose you have this sample space, and this sample space has the three disjoint event, that is A1, A2 and A3, and you have also the info about the probabilities of these events, that is A1, A2 and A3, right? That means you have the prior belief of these event. Now if I told you that this event B is there, so let's suppose if this event B is there, right, and what you do is you observe this B under each of the scenario, right? So you have the prior belief about this event A1, A2 and A3. That means you know the probabilities of these event. Now if I told you that this event B has occurred, now you should revise your prior beliefs, or you should revise your probability of this event A. Why? Because initially when I was not told that event B has occurred, initially our universe used to be this, right? And at the moment I told you that this event B has occurred, and now within this event B, now our universe will be confined to this, right? So our universe has got shrink, and now what we have is the conditional universe. So that means it's the time to revise our beliefs, initial beliefs, right? Because what was our earlier universe is not now, it has gone. Now this is our new universe, and you should revise your initial belief, right? And this is what the Bayes rule says, that you have some initial belief and you have some event B, and this observation of event B under each of the scenario that you have. Once you have this info, then you can make the inference about the event A under this scenario, or you are going to make revision of your initial belief given that this event B has occurred. So this is what the Bayes theorem is, right? And this is nothing but the conditional probability. So that would be nothing but the conditioning event. And here you will have the, so you have this info, right, that the probability of this event B under each scenario, and you have also the initial belief about your event, right? So what you are doing, you were having some initial belief and you are somehow making some revision of your initial belief, and this is what you will get as a revised probabilities of this event AI given this event B, right? And this is what the Bayes theorem is, right? And it is nothing but just a conditional probability, right? So if you have to reach to this point, so you can write this joint event, that is the probability of A intersection B, that is equals to happening of this event A. So once this event A has happened, what's the probability of this event B, right? And now you can bring this to left side, so from here, and you will have also the other form of it, maybe because this event B has occurred, and under this event B, what's the probability of this event A, right? So if you bring in the first equation, if you bring this to left hand side, so from here you will have the this conditional probability of this event B under this condition A, that would be nothing but the joint probability of this event A and B divided by the conditioning event, that is the probability of A. And from here also you can also write from this second equation that the probability of this event A given B is equals to the joint probability divided by the conditioning probability, that is the probability of this event B, right? So here in this the conditional in this Bayes rule, how do you find this probability of this event B? Since we know the probability of this event B under each possible scenario, right, and we also know the prior probability of this scenario, so we can make use of the what, total probability theorem, right? So probability of this event B under each scenario, and we also need to weight this conditional probability with probability of each possible scenario, and we need to sum, or we need to find this thing, and we need to sum this probability for all possible scenario, right? So this is how you get the conditioning probability of this conditioning event, that is the probability of this B, right? Now let's talk about this Bayes rule variation in terms of the discrete random variable. So in case of the discrete setting, let's suppose if you have this random variable x and you have some prior belief, that means you have the known PMF of this random variable x, right? Now let's suppose you have this another random variable y that is somehow related to this random variable x. So what you do is you observe this random variable y in each possible value of x, under the each possible values of x. So you are making observation of this conditional PMF, that is conditional PMF of this random variable y given x. Now once you have this information, what you can do, you will have to make revision of your initial PMF. That means now you are going to infer the probability, or sorry, the PMF of this random variable x given y, So we can make use of this conditional probability or the Bayes theorem to find the PMF of this random variable x given this y, right? How we can proceed? We can simply proceed using the multiplication rule. So the PMF of this random variable x and y, the joint PMF, that would be equal to the PMF of this random variable x times given this random variable x, what's the PMF of this random variable y, right? We can write the same joint PMF. Maybe if this y has taken first, y has taken some value, or this y has occurred first, so PMF of this random variable y, given this y has occurred, what's the PMF of this random variable x given y, right? And these two are the same, so from here we can find this by bringing this to the left hand side. So from here the PMF of this random variable x given y, that would be equal to the PMF of this random variable x times the conditional PMF of this random variable y under each observation divided by the PMF of this random variable y, right? And if you observe, this is nothing but the joint PMF, right? And this is the marginal PMF of this random variable y, right? So what you want to do, you have some prior belief of this random variable x, right? And you want to have the revision of this random variable x or under this given random variable y. So you are going to make some revision, right, of this random variable x given y, and this you can get from the Bayes rule, right? And this denominator part is nothing but the marginal PMF of this random variable y, right? And how you can find this marginal PMF? This marginal PMF of this random variable y is nothing. You can make use of the total probability theorem, because you know the probability of y under each possible value of x, right? So you can make use of the total probability theorem. So conditional PMF of this random variable y given x times the PMF of each scenario, right? And you are going to sum this thing over all possible values of x, right? Because if you recall, how do we find the marginal PMF? You sum over the other random variable, that is x, right? So this is how you can have the variation of the Bayes rule in terms of the discrete random variable. Now you can proceed similarly and you can find the Bayes rule variation for the continuous random variable. So let's look that also. So let's suppose you have this joint PDF, you have this random variable x and y, so we can proceed from the joint PDF of this random variable x and y. It will have the two form, maybe this x has taken some value, so PDF of this random variable x times this x has occurred, what's the probability of this y, so that means here we are going to write the conditional PDF of this random variable y, right? And maybe we could have another form of this joint PMF. Maybe we can say that y has occurred earlier, so PMF of this random variable y, and since y has occurred, what's the probability of this x, so the conditional PMF of this random variable x given y, and these should be equal. That means from here I can find the conditional PDF of this random variable x given y, that would be equal to this initial belief times the observe the random variable x under each possible values of observed random variable y under each possible value that x can take. That means the conditional PDF of this y given x divided by the conditioning event, that is the PDF of this random variable y, right? And how we can find this marginal PDF of this random variable y? So we just need to, we can find using the total probability theorem, right? So the conditional, we know the conditional PDF of y under each possible value that x can take. So we know this conditional PDF, and also we need to weight this conditional PDF with the corresponding probabilities that random variable x can take. So that means we are going to weight this using this conditional, using this PDF of x, and this we need to do and sum over the possible values of x. That means we need to integrate over all the possible values of x, right? So we have, you have already gone through that how we can find the marginal PDF, right? So this is the Bayes rule variation of the continuous case. In next video we will look one more variation where we will have one discrete and one continuous random variable. Here what we are trying to see is that both the random variables x and y are continuous random variable. Here both the random variables are discrete random variable. We will have the cases where this random variable x will be discrete and this random variable y will be continuous. Let me give you an example. Classification problem. What you do, you observe the height, that means the continuous random variable, and you try to classify that either it's a male or female, right? Another mixture Bayes rule variation problem could be in communication system. We send the discrete signals, that is 0 and 1. So this random variable x can take the value 0 and 1, and we send this signal over the noisy channel. That means this signal on the receiver side will have this signal that we have sent out, plus it will have the noise as well, right? And this noise we will be model this as a Gaussian random variable. That means continuous Gaussian random variable. So that means this y will be a continuous random variable. Now what we want to find on the receiver side, that we want to find what's the probability or how likely that this random variable x has taken the value 0, or how likely that we have sent the 0 under this noisy observation. We would like to find what's the value of x, or how likely the value of x is 0 or 1, whatever. So we will look at such kind of problem in further videos. I just want to give you the idea of the variation of this Bayes rule. That is it. Okay, see you in the next lecture. Thank you so much.